The topic clipping. If we wish to display only a portion of the picture, in this case we use a window that is used to select that particular portion of that picture which is to be viewed. So this process is known as clipping. The process of clipping determines which element of the picture has to be displayed on the screen so they are visible. The reversible of the clipping is known as the shielding, that is covering up a portion of the picture that is non-visible. And the algorithm selected for the clipping element that is generated in the shape of a rectangle for that whose sides are aligned with the coordinate axis, that is x extent is measured from x min to x max and the y extent is measured from y min to y max. So in this picture we can see that on the top left corner consists of y max x min coordinate and the right topmost corner consists of y max and x max coordinate and the bottom left corner consists of y min and x min coordinates and the bottom right corner consists of y min and x max coordinates. And the next is the point clipping. A point P of xy is inside the window if all the four inequalities are true. The following four inequalities are: if x less than or equal to x max, second one if y less than or equal to y max, third one if x greater than or equal to x min, and fourth one if y greater than or equal to y min. If any of these inequalities is false, the point P is not displayed. In this picture we can see that the point x1 y1 is inside the rectangle. So we can assume that this point has been following the four inequalities. So it is true. So it follows the point clipping. Next is the line clipping. So we divide the line segment clipping process into two phases. First, we must identify those lines which intersects the window and so need to be clipped, and second one we must perform the clipping. So this clipping has to be undergo any one of these clipping categories. There are three clipping categories. First one is visible, second one is non-visible, and third is clipping category or clipping case. So in first visible, the both endpoints of the line segment lie within the window, and in not visible, the line segment definitely has the line segment will be outside the window. And if there is a line segment from x1 y1 to x2 y2, it must satisfy any one of the following four inequalities, that is x1 x2 greater than x max, or x1 x2 less than x min, y1 y2 greater than y max, and y1 y2 less than y min. And the third one is the clipping category, the line which is not in the category 1 nor in category 2, it is clipping category. So in this picture we can see that the lines A, B and CD are under category 1, that is they are visible, and the lines E, F and G, H are under category 2, that is non-visible, and the lines IJ and KL are under category 3, that is clipping category. Next is Cohen-Sutherland's algorithm. This algorithm provides an efficient procedure for finding the category of a line segment. The algorithm proceeds in two steps. First step is assign a 4-bit code to each endpoint of the line segment. The code is determined according to which of the following 9 regions of the plane the endpoint lies in. In the below figure, we can see that there is 9 regions which consist of 4-bit code. Starting from the leftmost bit, each bit of the code is set true according the following steps. First one, bit 1 is true if endpoint is above the window, that is y minus y max is positive. Bit 2 is true if endpoint is below the window, that is y min minus y is positive. Bit 3 is true if endpoint is to the right of the window, that is x minus x max is positive. Bit 4 is true if endpoint is at the left of the window, that is x min minus x is positive. And a point with code 00 means that it is inside the window. And the step 2 is that the line segment is visible if both the endpoints codes are 000. So it is not, that is not visible, If the logical AND of the code is not 0, 0, 0 and a clipping candidate is logical AND of the endpoint, code is 0, 0, 0, 0. For example, consider this image. In this image, there are 3 line segments P1, P2, P3, P4 and P5, P6. And considering the line segment P1, P2, we must take the logical AND of this line segment. So, the P1 and P2 has the same 4-bit code, that is 0, 0, 0, 0, 0, 1. So, while logical ANDing takes place, that is 0, 0, 0, 1, logical AND 0, 0, 0, 1, the answer is 0, 0, 0, 0, 0, 0, 1. It means that P1 and P2 is outside the window, so it is non-visible. And next, consider the line segment P3 and P4. Here, while taking the logical AND of this segment, that is P3 and P4, it also has the same 4-bit code, that is 0, 0, 0. While ANDing this, we will get the same answer, that is 0, 0, 0. It means that this line segment is inside the window. And next is while taking the the line segment P5 and P6, the 4-bit code of the P5 is 1000 and the P6 000. So while ANDing the P5 and P6 4-bit code, we will get 0000. It means that it is inside the window, but it is partially inside the window. It means one part is outside the window and one part is inside the window. So we need to find the clipping. So we will take the intersection point of that P5 and P6 and we will mark that intersection point as P5 dash. And while taking that P5 dash and P6 for bit codes, then we should take the logical AND of that 2 points, that is P5 dash for bit code is 000 and P6 000. And while logical AND, we will get the 0000 answer. So it has been clipped. Next is the midpoint subdivision. The line segment, if a line segment is divided or its midpoint into 2 smaller line segments, the clipping category of the 2 new line segments are then determined. Each segment is categorized. Segment in category 3 is divided again into smaller segments and categorized. The bisection and categorization process continues until all segments are in category 1 or in category 2. The midpoint coordinates xm, ym of a line segment joining the position x1, y1 and x2, y2 can be calculated by xm equal to x1 plus x2 by 2, ym equal to y1 plus y1 by 2. And the next is the polygon clipping. A polygon is called a convex polygon if the line polygon, any 2 interior points of the polygon, lies completely inside the point. For example, 2 figures has been given. First one is the convex polygon, where the line P1 and P2 which lies inside the polygon, and the non-convex diagram, the line P1 and P2 lies outside the polygon. And a polygon with the vertices P1, P2 till Pn is said to be positively oriented if one of the vertices in the given order produces a counterclockwise circuit. And next, if a point P is to the right of any one of the edge of a positively oriented convex polygon, it is outside the polygon. If it is to the left of the every edge of the polygon, it is inside the polygon. So this observation forms the basis for clipping any polygon convex or non-convex against a convex positively oriented clipping polygon. Next is the polygon clipping algorithm. Otherwise, it is called as Sutherland-Hodgman algorithm. Let P1, P2 be the vertex line if the polygon to be clipped. Let edge E determined by the endpoints AB be any edge of the positively oriented convex clipping polygon. We clip each edge of the polygon in turn against the edge E of the clipping polygon, forming a new polygon whose vertices are determined as follows. And the images are given under. And next step is consider the edge Pi minus 1 Pi. If both Pi minus 1 and Pi are at the left of the edge E, then the vertex Pi is placed on the vertex output list of the clipped polygon. If both Pi and Pi minus 1 and Pi are to the right of the edge, Nothing is placed on the vertex output list. If pi minus 1 is to the left and pi is to the right of the edge, the intersection point I of the line segment with the extended edge E is calculated and placed on the vertex output line. If pi minus 1 is to the right and pi is to the left of the edge, the intersection point I of the line segment pi minus 1 pi with the extended edge E is calculated and both I and pi are placed on the vertex output list. And we can see that the polygon clipping the lines has been clipped in the order as left, right, then top, bottom. In this way, the polygon clipping has been taking place. The lines which are inside only the window has been taken, and the lines which are outside the window is not taken. And the lines which intersects, if a line is coming from inside to outside in a window clipping, only the out inside line has been taken, not the outside line is taken. The line which has been till the which intersects the window, only up to that line only the polygon clipping has been taking place. So the algorithm proceeds in stages by passing each clipped polygon to the next edge of the clipping window. Next is the text clipping. It is the process of clipping the string. In this process, we clip the whole character or only some part of it depending on the requirement of the application. There are three text clipping methods. First one, all or none string clipping method. In this method, we consider the whole string which is inside the window. We only consider that string only. And this string is mainly inside a rectangle bounded. So the boundary position of the rectangle are then compared with this window boundaries also. So if a string has been overlapped within the window boundaries, then that string has been rejected. Only this string which is inside the window has been taken only. And next is all. Second one is all or none character clipping method. In this method, we keep the characters of the string which lies inside the clip window and remove all the characters which lie outside the window, and it will check the boundary limits of the individual characters to the window. Here also the overlapping has been also checked. In previous step, if we are checking the string, in this method we are checking the character. If any character has been overlapping the clipping window, that particular character has been removed. In this example, we can see that SHREY, that H has been overlapped the window clip, so that the H and S has been completely removed. And next is the text clipping method. In this method, we keep the characters of the string which lies inside the clip window and remove all the characters which lies outside the window. Here also, if any character overlaps the window boundary, then we keep that part of the characters which lies inside the window. It may be partially, and the other part has been discarded. In this example, SHREY, the H has been the half part of the edge has been kept inside and other has been discarded. Next is the exterior clipping. The exterior clipping is the process in which we consider and save the object which is outside the window plane and discard the part that is inside the window. And we use exterior clipping in many purposes. It is used for overlapping the pictures in our application. It is used in marketing and advertising. We can use it in multiple window system. Then exterior clipping helps in designing picture patterns. We can use exterior clipping in publishing. We can also design and represent the map and characters with the help of exterior clipping.